Hi everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about how to factor a negative quadratic equation with a first coefficient that's greater than 1. That's a mouthful, right? Well, it also can be quite daunting to do the math for it. And what do we mean by this? This is what we're talking about. When I have a quadratic, that is, there's an x squared, and that is my biggest term, my biggest exponent, and it's in this form where there's a coefficient in front of the x squared, there's a coefficient in front of the x, and then there's a plain coefficient by itself. X squared being the key. You could have a 0 for either of those, but you have to have a number in front of the x squared. That's what we're talking about, that form, and we're asked to factor it. And that first coefficient, that a, is both a negative and also greater than 1, any number that's greater than 1. Now, for any sticklers out there that hear me say that and go, but negative 2 is not greater than 1. I'm referring to just this number in isolation, and I'm treating the negative like a separate entity for the purposes of this conversation. Okay? All right, now that we've settled that, moving on. So I have this negative 2 or negative 3, negative 4, whatever it is, in front of the x squared. How do I deal with this? You're going to use two skills which you may have already learned in algebra. The first is how to deal with a negative x squared. The other is how to deal separately with a positive coefficient greater than 1. If you've done these two things before, I'm going to give you the little shorthand explanation, is do this part first, deal with the negative, pull it out, and or get rid of it, depending on if it's an equation equals 0. And then move on and treat it this way with that coefficient greater than 1. Now, if that meant something to you and now you're like, oh, okay, I can go on my merry way, that's great. If this is unfamiliar territory, don't worry, we're going to go over all of it and you'll have everything you need either way. So first, I'm going to be treating this as something that is not equal to 0. It's not an equation. I'm just dealing with the factoring. Once you've factored it, you can solve for it, equal 0 if that's what you're dealing with. So this will help, everyone, whether it's equal 0 or not. First thing you want to do is you want to pull out that negative 1. The negative 1 comes out of everything. It's just going to change the sign all the way down. So negative 2x squared becomes positive 2x squared. Negative 11x becomes positive 11x. And positive 40 becomes negative 40. And now I'm going to just deal with this, and I'm going to pretend that negative 1 is not there. Again, if this is an equation and equals 0, you could at this point get rid of the negative 1 by dividing everything on both sides by negative 1. But if you are just factoring, not the negative, not equal 0, you can't forget about it. You have to take it along for the ride. Okay, so I'm going to go over here separately. Handle this 2x squared plus 11x minus 40. This is not my main factoring area. That negative 1 is still there. I'm just dealing with this by itself. So some students, especially when it's a 2, a prime number, a 2, a 3, a 5, they like to, I call it like the guessing game, where they're like, oh, 2x squared, so I know it's prime, so 1 has to be 2x, 1 has to be x, and then I can just take factors of this and stick them in here, and just keep sticking them in until I get 11 when I multiply things together, and yeah, that's going to be it. Will that work? Well, yeah, it will. Is it the fastest method? Is it the most efficient method? Not really. It can feel less daunting. It can feel like you can, wrap your head around it a little more easily. And there's nothing wrong with that. It's fine. There's two things to consider is that one, it can be very time consuming, especially when we have a negative. Why would I say the negative would make a difference? Because what are you going to have to test here to find this, where I multiply 2x times this coefficient, this term, and this term by x, add them together and get to 11. How many different things, possibly, am I going to have to test? Well, what are the factors of regular 40, just positive 40. 1 and 40, 2 and 20, 4 and 10, and 5 and 8. And when there's a negative involved, I have to do them all over again because I have to have two pairs. That one negative, that one negative, that one, that one, that one, that one. So one of the pair is like -1, or is it -40? Is it -2? Is it -20? So I have 8 different combinations. It's possible I may end up going through all of them before I find the right one. We don't know. That's a lot. That's a lot of work. Also, your teacher may not like you doing that way. They may want you to do it the quote-unquote proper way. If you are given free rein, of course, do it whichever way you prefer. Here's the way that will help you no matter what that first coefficient is. Okay, first thing you're going to do is you're going to multiply these two together. 2 times -40 is -80. Now, this one, you're going to look at all of the factors. And you're like, hey, Alyssa, you just said that the other was too hard when you're writing out the factors. Yeah, I did. But in that case, every single time, you're going to have to take those factors, multiply that by 2, do that by 1, and then add them together. This one, this method I'm talking about, simplifies that in this one critical way. Let's write down all the factors of 80. And I'm going to have to do them twice because it is the factors of -80. So -1 and 80, 1 and -80. -2 and 40, 2 and -40. -4 and 20, 4 and -20. And then let's see, 5. Yeah, 5 goes into that. -5 and 16. Think about that for a second. 5 and -16. Now, as you're doing this, as you go, you don't have to keep going further. You know, and what I say by this is it's sometimes very helpful to kind of be looking for two numbers that are 11 apart. If they're 11 apart from each other, it's going to work, right? So as we're going down this list, -1 and 80, no. 2 and 40, no. Those are 38 apart. 4 and 20, getting closer, but 16 apart. Wait a minute. 16 and 5 are 11 apart. So which pair is it? Positive 11, so that's going to be positive 16 and -5. If I add those together, I will get to 11. So I think that just adding those two numbers together, seeing which ones would add to 11, is easier and less prone to error than having that 2x, x, we have those other terms there, 2x times that term, that times x, and then adding them together. This is a more straightforward way of doing it. So -5 and 16 together are 11. Now that I have those two numbers, what do I do with that? What do I do with that -5 and 16? I'm going to write -5x, and I'm going to write positive 16x. And then I'm going to put that 2x squared there, and I'm going to put the -40 there. How did I know which one to put first? I didn't, and it doesn't matter. Once you go through this process, you will get the exact same answer no matter which one you put in front. I promise you, 100%, no exceptions. So here's the method. Once you've separated this 11x into the -5x plus 16x, you're going to pair them together. And then you're going to look for a factor in each set. So here, this first pair, 2x squared minus 5x. Is there any common factor in 2 and -5? No. X squared and x? Yeah. So I can pull out an x, and I'm left with 2x minus 5. Over here, 16x minus 40. I'm going to look for that greatest common factor of them. Spoiler alert, it's whatever I can pull out that will leave 2x minus 5. If you cannot leave 2x minus 5, that same binomial, again, something's gone wrong. You've messed up. it's a good thing to know. We don't want to get the wrong answer, do we? No. So this is a perfect way of telling. If you pull out the factor, in this case, it's going to be 8, because 8 times 2x is 16x, and 8 times negative 5 is negative 40. If you pull out that greatest common factor and you do not get the same thing in both places, something's gone wrong. We need to go back and look. In some situations, it can be as simple as changing it to a negative number, and that changes the signs, things of that sort. Okay, once you've done that, you're home free, honestly, because these become our first binomial, and then this is our second binomial. So x plus 8, 2x minus 5. And now I have factored over here, and I can go back up to here. So my final factoring is negative 1 times x plus 8 times 2x minus 5. And generally the 2x minus 5 is written first. The one with the bigger coefficient is usually written first. And there I factored it. Now some teachers are going to want that negative 1 to be distributed. Do not make the mistake, please, of trying to distribute it through the whole thing. Just pick one of them. Multiply the negative 1 just times this, or the negative 1 just times the x plus 8. So please, please just do that. Again, that depends on your teacher. Some don't like the negative 1 out front, and it confuses them. I hate to say that way. That sounds horrible, but I've seen that happen. So just FYI, you may need to multiply it back in your final factoring. As a little side note, if you are wondering why this works, why can we do that? It's, even though go away, little pop-up. Even though the numbers, the binomials that we're dealing with look a little funny, a little different, look at it this way. If it was, I'm going to replace this x with a 5, and this 2x minus 5 with just a 3. And the 8 I'm going to leave alone. I'm going to replace that 2x minus 5 with another 3. So if I had 5 3's and I had 8 3's, how many 3's do I have? I would have 13 3's, right? 5 3's and 8 3's. I have 13 3's. Or we could say 5 plus 8, 13 3's. That's all we did. I have x, 2x minus 5's, and then I had 8 2x minus 5's. How many 2x minus 5's do I have? X plus 8. That's what's going on. So it's not something, weird or strange. It just looks strange because we have variables in parentheses, but it's a concept you've used a lot. Editor Alyssa popping in here with something I realized I forgot. Once you've gone to this grouping stage where you've already separated that middle term and you're ready to group things and pull out those factors, there is a situation you are likely to encounter at one point. So let's say you've already pulled out your factor on the first one, and then you get to the second one and you're like, wait, x plus 2, there's nothing to pull out of there. So, okay, my answer is just 2x times x plus 2, because I'm just going to have an x plus 2, right? And there's nothing there to pull. No, if you multiply this back in together, it's not going to work. Why won't it work? Because I don't have just 2x, x plus 2's. I have 2x, x plus 2's, and I have one more x plus 2. So it's going to be 2x, x plus 2's, and one more x plus 2. So in other words, we pull out 1. It's like, pull out a 1? Yeah, you have to have that 1 there to represent that there's another x plus 2, not just 2x, x plus 2's. So it's 2x plus 1, x plus 2's. That throws a lot of students. Just don't make that mistake. So whenever you see where it looks like, oh, it's already factored, there's nothing to pull out a 1, and then all your math will work out good. Okay, even though that was lengthy, I'm going to do one more here, and it's this other one. One of the most common ones you're going to see is where this first one is not a prime number. And then that method where we're just guessing and plugging things in really goes out the window, because then you can't just put, like in the previous one, 2x and x. You'd have to account for 4x and x, or x there, or 2x and 2x. And then also dealing with the, come on. It's so many variables. It's so easy to miss something. But when we do it the other way, even if it seems a little more complicated at the beginning, it's consistent. It takes about the same amount of time every time. So especially if you have a test, you can count on how long it's going to take you. Once you've practiced and you know yourself, you know how long it's going to take you. Okay, remember our first step is to pull out that -1. So I'm going to pull it out of the whole thing. It changes the sign of everything. Negative 4x squared becomes positive 4x squared. Negative 17x becomes positive 17x. And positive 15 becomes negative 15. All right, now I am going to deal with this over here in a different color. So 4x squared plus 17. I forgot that x. Shame on me. X minus 15. And I'm going to do that same thing that I did before. I'm going to figure out how to group it by multiplying the first term and the last term together. Do include the positive or negative. So 4 times negative 15 is negative 60. Okay. So positive and negative. I have to have one positive and one negative. All right. And we want a pair of numbers where they are 17 apart. And then we figure out which one needs to be positive and negative. In this case, because it's positive, spoiler alert, the negative number is going to be smaller. But you'll see that in a second. All right, so negative 60. What multiplies to negative 60? 1 and 60. I don't even really have to consider which one should be a negative because those are not 17 apart, right? They are 59 apart. 2 times 30. All right, it could be the negative 2 or it could be a negative 30, but it really doesn't matter because, cross those out, because 2 and 30, that's 28 apart. All right, the next one, does 3 go in? Yeah, it does. 3 goes into 60 20 times. Hey, 3 and 20, that's 17 apart. All right, now let's look at them. We got negative 3 and positive 20, or 3 and negative 20. Positive 17, so the bigger number needs to be the positive one. 20 minus 3 is 17. So negative 3 and 20, those are my numbers. This time, I'm going to put the bigger one first, just to show you it does not matter at all. I will always get the same answer. All right, 4x squared plus 20x minus 3x minus 15. Now, sometimes when you're grouping this, if there's a negative right here in the middle, it can cause some confusion. Something I like to do is to change it to a plus a negative, and then it's very easy for that negative to go with that 3. Okay, I'm going to group it into 2 groups. First one, 4x squared plus 20x. Is there a common factor in 4 and 20? Yep, 4 goes into both of those. Is there a common factor in x squared and x? Yes, indeedy, that is an x. So 4x times x equals x squared, and 4x times 5 equals 20x. All right, now here I've got negative 3x minus 15. Remember, I want to pull something out, so x plus 5 is left behind. And if I can't do that, I've done something wrong. So to leave a positive x and a positive 5, I need to pull out a negative number. What is the greatest common factor of 3 and 15? In this case, negative 3 and negative 15. Well, it's going to be 3. And remember, I need to pull out a negative to leave positives inside that parentheses. Pull out a negative 3. Does that work? Yes, because negative 3 times x is negative 3x, and negative 3 times 5 is negative 15. All right, then these two become my new little binomial here out front, 4x minus 3. That x plus 5 stays, and then I factored so I can go back over. And my final factoring is negative 1 times 4x minus 3 times x plus 5. And again, just depending on your teacher, they may not like that negative 1 sitting out front. Like, why the hate on the negative 1? I don't know. So they may want you to distribute it into either the first binomial or the second binomial. So what that would look like, just to finish this up, if I did it into the first one, negative 1 times 4x is negative 4x. Negative 1 times negative 3 is positive 3. So it'd be negative 4x plus 3 times x plus 5. The other alternate version is if I multiply the negative 1 times this whole binomial. So negative 1, let me zoom out a little bit more. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. And that 4x minus 3 stays as it is. All three of these things are exactly the same. If I multiply, if I distribute each of these using FOIL, I'm going to come back to this same quadratic of negative 4x squared minus 17x plus 15. All three are correct. Again, it just depends on your teacher, which way they want you to present it. And there you go. Hey guys, this video was helpful or useful in any way, please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.